this video, I'd like to discuss the three most common supports for beams. So in this diagram, we have a pin support, a roller support, and a fixed support. Okay, so why are we bothering with these supports? Well, if you remember back to Newton's law, we know that every action has an equal and opposite reaction. Remember? So if we have a wall here, and I push on this wall like that, it's going to have an equal and opposite reaction, just like that. Because otherwise the wall would just move. Okay, so we're going to try and implement this theory for these supports. So think about what would happen if I was to push this beam in this x direction here. What do you think would happen? Well, it's not going to move because it's literally pinned to the ground. Okay, so instead we're going to have an equal and opposite reaction, like that, in the x direction. In the same way, what would happen if I was to somehow try and lift this beam, like that? Well, again, it's not going to move because it's literally pinned to the ground. So it's going to have an equal and opposite reaction like that, in the y direction. Alright, so what if we try then to rotate this beam? What if we try and rotate this beam like that? Well, because it's a pin support, it's actually going to allow us to rotate. So we're not going to have a moment reaction for this support. Okay, that's important. Alright, so let's look at the roller support. If I try and push down on this roller, it's going to push straight back at me. So we have a y reaction force. But if I try and move it in the x direction, it's going to move because we have wheels on the support. Just going to move. So we're not going to have a reaction in the x direction for this support. And similar to the pin support, if we can rotate this, okay? We can rotate it. So we're not going to have a moment reaction either. So let's finally look at the fixed support. I can push this beam sideways. I can push it upwards. And it's not going to budge. So in this case, we have both reactions. Okay, so a reaction like that, and a reaction like that. So y and an x reaction. And this time, if I try and rotate this beam, it's not going to let me do that. Because remember, it's fixed to the ground. So this time, I'm going to have an equal and opposite moment reaction. So I hope these different types of reactions make sense. Okay? And this is the notation that we commonly use in free body diagrams. And this knowledge is going to be critical when we look at structures like this truss and try and determine the forces which act on it. So if I put a force like that, how is that going to interact with the truss? Okay, so for something to be what we call statically determinate, which means something we can easily solve using our simple mechanics, we need to apply the statically determinate formula, okay? And that formula is m equals 2j minus r, okay? And what do these variables stand for? Well, m stands for members, j stands for joints, and r stands for reactions. Okay, so this r is what we just discussed previously. So let's have a crack at this truss here. Is it statically determinate? Can we solve this truss? Can we solve for the forces in this truss? Okay, well, how many members does it have? Let's count them. 1, 2, 3, 4, 5, 6, and 7. Okay, so it has 7 members. 2 times by the number of joints. How many joints do we have? Okay, so we have one joint here. We have another joint here. I might circle them to make it easier. We have another joint here, 3. Another joint here, 4. And we have another joint here, 5. Okay, so we have 5 joints. Minus the reactions. Okay, so I don't know if you can see this because I've kind of written over it, but let's try and, there we go. So have a look at these two supports. What reactions are they going to have? Remember, this here, what's this one here? It's going to be a pin support. And what's this one here? This is going to be a roller. And what did we learn previously about the reactions for pin and roller supports? Let's go back. So pin, it's going to have an X and a Y reaction. Okay, X and a Y. And the roller, that's just going to have the Y reaction. Okay, and that's going to be a normal reaction like that. So how many reactions do we have in total? 3. 1, 2, 3. Well, does this formula work out? 7, does 7 equal 10 minus 3? Yes, it does. Okay, so now we know we have a statically determinate truss, which we can solve.